Okay, in this presentation, we are going to calculate mole fraction if density is given. So let's take an example. A bottle of bourbon is labeled 94 proof, meaning that it is 47% by volume of alcohol in water. What is the mole fraction of ethyl alcohol, C2H4OH, in the bourbon? The density of ethyl alcohol, it is 0.80 gram per milliliter. So that means 1 liter of bourbon contains 470 milliliter of alcohol and 530 milliliter of water. To solve this problem, we need to convert the volume of ethyl alcohol to mass using density, and then convert that mass to moles using molar mass. So let's go to next slide. We have 470 milliliter of ethyl alcohol, multiply its density 0.80 grams per milliliter. We convert into grams, and then we divide by its formula weight of ethyl alcohol, which is 46.08 grams. We got the mole of ethyl alcohol. Now we have 530 milliliter of water, and we multiply by its density, which is 1 gram per milliliter. We convert to grams. Here you can see milliliter cancels. 530 times 1, which is 530 grams, and then we divide by its 18.0402 grams formula weight. You get 29.4 mole of water. So now we have total moles 8.16 ethyl alcohol plus 29.4 moles of water. So total we have 37.6 mole. Now we need to calculate mole fraction of ethanol. We have 8.16 grams of ethyl alcohol divided by total mole, which is 0.22. Alright, so now we can calculate mole fraction if molality is given. So let's see, 3.6 m solution of calcium chloride, CaCl2, is used in tractor tire to give them weight. The addition of CaCl2 also prevents water in tires from freezing at temperatures above -20 degrees Celsius. What are mole fractions of CaCl2 and water in such a solution? Now we have 3.6 molality solution, which means we can interpret 3.6 mole CaCl2 in 1 kilogram of water. To solve this problem, we can convert mass of water to moles and then compute mole fraction, because here we have m, small m is given, and we need to find mole fraction. Okay, so now we have moles of solute, which is CaCl2. It's given 3.6 mole, and which is in 1 kilogram of water. So we convert 1 kilogram of water to grams first. Kilograms cancel. Using this conversion factor, we have 1000 grams of water, and these 1000 grams of water divide by formula weight of water, which is 18.02 grams. So we convert these grams to moles, which is 55.5 moles of H2O. So now we have moles of CaCl2 and moles of H2O. Now what are the total moles? We have 3.6 mole CaCl2 plus 55.5 moles of H2O. Total mole is 59.1 mole. Now we can easily calculate mole fraction of CaCl2 and water also. Moles of CaCl2 in that solution, which is 3.6, divided by total moles, which is 59.1 mole, and you can calculate mole fraction. Now let's calculate about H2O. H2O has 55.5 moles in that solution and total moles is 59.1 mole. So mole fraction of CaCl2 0.061 and mole fraction of H2O is 0.94. So if molality is given and we can convert into moles and then we convert into mole fraction, we can calculate that. We can convert between molality and mole fraction. It is relatively simple because you know the masses or moles of both solute and solvent. So it's easy to convert. Now let's say a solution contains 8.89 times 10 raised to minus 3 mole fraction of I2 dissolved in 0.9911 mole fraction of CH2Cl2 methylene chloride. What is the molality of I2 in this solution? Now in this case mole fraction is given and we need to calculate molality. So we'll assume we have 1 mole of the solution and we begin with 8.89 times 10 raised to minus 3 mole of I2 and 0.9911 mole of CH2Cl2. And next we'll convert moles of solvent into grams and then into kilograms and then we compute molality. So we have moles of solute which is 0.00889 moles I2 and we convert kilogram solvent. So we have 0.9911 mole and then we multiply its formula mass. CH2Cl2 formula mass is 89.93 grams. Once we convert into moles to grams, we convert into kilograms multiplied by this conversion factor. We know that 1 gram equals 1000 gram. So we can convert moles to kilograms of CH2Cl2. And then we can calculate molality. Moles of solute which is 0.00889 and kilograms of solvent which is 0.08417 kilogram. And that's the molality, 0.106 mole per kilogram. So that means if mole fraction is given, you can convert into molality, or if molality is given, you convert into mole fraction.